Okay, we'll continue on with Laplace transforms. So in the last lecture, we kind of introduced the definition. This time, let's look at a system. If we have an input and an output, very similar to what we've seen with the Z transform. If I have a system G and some input U and some output Y, now in continuous time, and it's described by some differential equation. Like we saw last time. The Laplace transform method tells us to take a couple steps, as we talked about last time. First, you apply the Laplace transform to the differential equation to turn it into an algebraic equation. Then we carry out the algebraic manipulations. And then finally compute the inverse Laplace transform. To solve the original differential equation. Now, we've seen this before. This type of operation is similar to logarithmic operations. And there we transformed multiplication into addition. So if you recall, we would take the log of xy. And now, if we have logarithmic tables, we can take the log of x and the log of y and add those together to find the product. Xy equals the inverse log of log x plus log y. However, to do this, we need logarithmic tables. So in this sense, the Laplace transform uses tables. Something like this. F of t on the left-hand side and f of s on the right-hand side. And as we saw last time, the unit step function, or the constant function, transforms into 1 over s. A couple other ones that we'll use is if the continuous time function is e to the minus at, that's 1 over s plus a. A couple more. Sine of omega naught t is omega naught over s squared plus omega naught squared. And similarly, cosine omega naught t is s over the same denominator, s squared plus omega naught squared. One more set of them we'll look at is a envelope function of the sine. So here's a sine wave with an exponentially decaying sine wave if a is greater than 0. And that's given by, the Laplace transform is given by omega naught over the quantity s plus a squared plus omega naught squared. And similarly, if we have an exponentially decaying envelope, of course if a is greater than 0, of cosine omega naught t, we get s plus a in the numerator over the quantity s plus a squared, same denominator as before. So these tables are what we'll use to find the inverse transform. We'll put it in a form that we can inverse transform easily using these tables.